Okay, there are going to be a lot of steps to use Cramer's rule to solve systems of equations, so kind of buckle up. We're going to turn these systems into a special type of matrix. So what you're going to do, I'm going to show you the first part. We're going to turn this part into a 2 by 2, but instead of putting a closed bracket, we're going to do that. And what you end up doing, you don't bring down the x's and y's, just the coefficients. So a would be -2, b would be 4, c would be -6, d would be -3, and then the solutions over here would be -8 and -24. All right. And then what you're going to do, and this would tell you to find a system of equation. What you really need to do, so here are the steps. You're going to set up 3 different matrices. The original, which is right here, and then there's going to be an X matrix, an X 2 by 2 matrix, and there's going to be a Y 2 by 2 matrix. And then you're going to find the determinant of each one. So this is going to be the determinant of the X. This is going to be the determinant of the Y. And when you do that, you're going to find the 3 determinants, and then you're going to list them, and then you're going to solve for X and Y. X, the X value, will be the X matrix determinant over the original determinant, and then the Y value will be the Y determinant over the original determinant. So let's see what that looks like. So here's our original matrix: -2, 4, -6, -3, and remember it's A times D, -2 times -3, and we're going to subtract B times C, 4 times negative. So -A times D, -2 times -3, which is 6, subtract, and then B times C, 4 times -6, which is -24, but subtract negative is adding to positive. 6 plus 24 is 30. So that is the D determinant. The original determinant is D is equal to 30. Now, to make the X matrix, get all that. This is what you're going to do. You're going to look at that original matrix and imagine this is the X column and this is the Y column. Instead of the X column, you're going to replace the X column with the solution column. So that's -8, -24, and then you're going to leave the Y column as it is. So let's see if that's what I did here. Yep. Let me erase this now. So the solution set replaces the X, and then the other column is the original. And then you're going to find the determinant of that. -8 times -3, which is +24, subtract 4 times -24, which is -96. So 24 subtract a negative is like adding a positive. 24 plus 96 is 120. So that's the determinant of X. All right, then you're going to find the Y. And what you're going to do is you're going to take these and you're going to cover up the Y values. So here is the original -2 and -6. And where the Y values were are now the solution values, -8, -24. You're going to find the determinant. -2 times -24 is +48. Subtract -8 times -6. So this is 48. Subtract 48. Well, that's easy. So the Y determinant is going to be 0. So now we have the original determinant, which is 30. We have the X determinant, which is 120, and we have the Y determinant, which is 0. And remember what we said, the X value is the determinant of dx, which is 120, over the original, which is 30. So 120 divided by 30 is 4. So the x value is 4. So the y value, it's the determinant of the y, which is 0, over the original determinant, which is 30. Well, 0 divided by any number is 0, so y is equal to 0. And then you're going to put those in the solution set brackets, just like that. Okay, that is it for Cramer's rule. If it's a 3 by 3 matrix, it will be a much more complex, but for the 2 by 2, that's it.